Another way to justify if the given graph below represents the given polynomial function is by doing the actual factoring of the given polynomial function. So we have here p of x is equal to x squared times x plus 5 times 4x squared minus 36. Looking at the given, x squared is already in factored form as well as x plus 5. But the 4x squared minus 36 can still be factored out. So therefore, let's try to factor that out. Try to factor 4x squared minus 36. So this will become x squared times x plus 5. And 4x squared minus 36 is actually difference of two squares. So when we factor this out, this will become the factors of 4x squared are 2x and 2x. And then the factors of 36 are 6 and 6. And since this is difference of two squares, all we have to do is to assign positive for the first one and then negative for the second one. So there you have it. These are the four factors of the given polynomial function. And if we will be rewriting them into zeros, let's identify the values for x. So we have here x squared equated to 0. We also have x plus 5 equated to 0. We also have 2x plus 6 equated to 0. And lastly, 2x minus 6 equated to 0. Now, let's solve for the values of x. Since this is squared, the square root of x of 0 will be x is equal to 0. Since it is squared, 0 is a multiplicity of 2. Meaning, the factor for x is used twice because it is a second degree factor. Now let's solve for this. So we will have here x is equal to -5. In here, we will have 2x is equal to, suppose, change the sign, it will become -6. Divide both sides by 2. So x is equal to -3. And finally, we have here 2x is equal to, and we transpose -6, it will become +6. Divide both sides by 2. So we will have here x is equal to 3. There you have it, the four zeros of the given polynomial function. So we have x is equal to 3, x is equal to -3, x is equal to -5, and x is equal to 0 with the multiplicity of 2. Let's check and verify it in the given graph. So we have here x equal to 3, that's a 0. Another 0 is x equal to -3. There it is in the graph. And we have -5, that's the 0 in that graph. And x is equal to 0 with the multiplicity of 2 is this part. And if we will look at it, since it is a multiplicity of 2, the behavior of the graph then will be as it touches, as the graph touches the 0 with the multiplicity of 2, after touching it, it will immediately turn. So therefore, the movement or the behavior of the graph matches the zeros of the given polynomial function. And if we will look at it, it's a 5-degree polynomial function because we have here squared, linear term, and another squared. When we get the degree, it's a 5-degree polynomial function. So therefore, to know the number of turns, we will have 5 minus 1. That becomes 4 turns. And if we will verify it in our graph, we have here the first turn, second turn, third turn, and the fourth turn, which also verifies the given polynomial function. So there you have it. This graph, this given graph is actually the graph of our polynomial function, which is p of x is equal to x squared times the quantity of x plus 5 times the quantity of 4x squared minus 36.